We'd like to touch three important points today. The first one is how to architect the cloud-native software, and I'd share a little bit of the insights and the experience that we have made when re-architecting or transforming our software into a cloud-native architecture. Before we start, there's a lot of promises out there that the cloud and the cloud-native ID makes. Everything gets fast, agile, prosperous, we get all rich. But I'd like to ask Robin to give us a little bit of an insight about what customers are really asking for.
We put a lot of customers at the center and started talking to them as to what do they really want. And we got very specific feedback. So that's where we started to define what really does cloud native mean. And in addition to that, how do we approach that journey? So Andreas, do you want to take us through?
Thanks, Robin. I'd like to look more into the very technical aspects of that. How do we address cloud native? What do we mean with cloud native software engineering when we design our solutions? It's well understood that the software itself, cloud native software, is delivered through containers, microservices, and run and operated in containers. It's getting a bit more tricky when we look at the other layers. Of course, compute storage is available in the cloud, public or private. The biggest complexity, though, is in this middle layer. So to operate your application runtime environment, where you have to deal with all the complexity of the security, scalability, robustness, monitoring, the batching and upgrading of this infrastructure. When we talk about cloud native, what we actually really mean is that we leverage managed services for this infrastructure in the cloud so that we can offload this complexity to the provider of the public cloud. Like on AWS, as you see here, for the examples that we saw before, the Amazon RDS service for a completely managed database, Oracle or Postgres, the Elastic Container Service for Kubernetes, the Elastic Search Service, the Simple Queuing Service. And that's the architecture that we look at when we develop software. It's not only containers, it's also the things that we are running on. The next challenge that comes then is you have the application, you have it cloud native, it scales, everything is great, but then you have to deal with the integration challenge. And that's where actually the power of open APIs comes in. This is a very simple example that we've implemented in the customer. We have completely delivered the whole integration as serverless applications. And this is literally delivered in days. There is no more whole development teams for weeks and months. When you have an application with these open APIs, suddenly, again, serverless technology in the public cloud helps you dramatically to speed up the integration challenge, the automation challenge.
I think the most important part here is to continuously leverage the value from the cloud. If you stick to just compute, storage, and networking, you're not leveraging the other 167 services that Amazon offers. And what Herring Point has done a fantastic job of is to leverage our Kubernetes services.
And we're now, with our digital platform solution, ended up in a completely cloud-native architecture. We deploy the full application using Docker containers running on AWS services and can therefore remove all the complexity of dealing with this infrastructure.